In this lecture, I am going to present how to determine the static indeterminacy of a rigid jointed plane frame by two approaches. First, I will explain briefly how to determine the static indeterminacy by two approaches. Then I will explain some examples on rigid jointed plane frame. What is statically indeterminate structure? Statically indeterminate structures are those structures which cannot be analyzed with the help of equations of static equilibrium alone. These structures are also known as hyperstatic structure. In this structure, the number of unknown is greater than the number of independent equations derived from the condition of static equilibrium. So, the additional equations based on the compatibility of deformation must be written in order to obtain a sufficient number of equations for the determination of all the unknowns. The number of these additional equations necessary for the solution of the problem is known as the degree of static indeterminacy, or this is also called the degree of redundancy. The static indeterminacy of rigid jointed plane frame can be determined by two approaches. In first approach, we have to find out what is the degree of static external indeterminacy and what is the degree of static internal indeterminacy. So the total degree of static indeterminacy is equal to ds is equal to dsc plus dsi. The degree of static external indeterminacy for a plane structure can be determined using this equation. dsc is equal to r minus 3. And the degree of static internal indeterminacy for a rigid jointed plane frame can be determined using this expression. dsi is equal to 3c. c is the number of cuts, because at each cut 3 reaction components are released in the case of plane structure. So the equation is dsi is equal to 3 into c, where c is the number of cuts. Then coming to the second approach, so in this approach, the degree of static indeterminacy of a rigid jointed plane frame can be directly determined. We know every member of a rigid jointed plane frame carries three unknown internal forces. First, an axial force, a shear force, and a bending moment. The total number of external direction component is equal to r. So the total number of unknown forces, that is equal to 3m plus r. So 3m is the internal member forces and r is the external direction components. So the total number of unknown is equal to 3m plus r. But we know at each joint, in the case of rigid jointed plane structure, there are three static equilibrium equations provided. The condition of static equilibrium provides three equations at each of the j joints. If j is the number of joints, then the total number of independent equation is equal to 3 into j. Then the degree of static indeterminacy can be determined using this relation. That is, the total number of unknowns minus the total number of independent equation. The total number of unknown is equal to 3m plus r, and total number of independent equation is equal to 3 into j. So the degree of static indeterminacy is equal to 3m plus r minus 3j. where M is equal to number of members, R is equal to number of reaction components, and J is equal to number of joints. So using these two approaches, the degree of static indeterminacy of rigid jointed plane frame can be determined. Then coming to some examples, coming to the first example, determine the degree of static indeterminacy of a frame. This is the frame, and here this is one support and this is another support. Both supports are fixed support, and here the degree of static indeterminacy can be determined using this equation, ds is equal to 3m plus r minus 3j. So here you have to count the number of members, number of joints, and number of reaction components. So here how many members? 1, 2, 3, 4, 4 members. So M is equal to 4. And how many joints? 1, 2, 3, 4, 5. 5 joints. So J is equal to 5. How many reaction components? So here there are 3 reaction components, and here there are 3 reaction components. So total number of reaction components is equal to 6. So R is equal to 6. Then put these values in this equation. So ds is equal to 3 into 4 plus 6 minus 3 into 5. Then here 18 minus 15, so this is equal to 3. So the degree of static indeterminacy of this frame is equal to 3. Using the second approach, also you can find out the degree of static indeterminacy. If the frame is open, that is internally determinate. If the frame is open, then that is internally determinate, that is dsi is equal to 0, and dsc is equal to r minus 3. So here r is equal to 6 minus 3. 6 minus 3 is equal to 3. So in this case, using the second approach, also you can find out the degree of static indeterminacy. So the degree of static indeterminacy is equal to ds is equal to dsc plus dsi. So dsc is equal to r minus 3. So here the total number of reaction is equal to 6. 6 minus 3 is equal to 3. And dsi, this is equal to 0. The degree of static internal indeterminacy is equal to 0 because this is open figure. So here there is no loop. Any open rigid jointed structure is a determinate structure. So here internally this is determinate and externally this is indeterminate. Internally dsi is equal to 0 and externally dsc is equal to r minus 3, that is 6 minus 3 is equal to 3. So ds is equal to dsc plus dsi. So ds is equal to 3 plus 0 is equal to 3, and this is the ds. So you can find out using the two approach. So what is the degree of static indeterminacy? Then coming to the second example. So here this is the frame, and this support is fixed support, and this is hinge support, and this is 3 members. The degree of static indeterminacy can be determined using this formula, ds is equal to 3m plus r minus 3j. So here count the number of members, number of joints, and number of reaction components. So here 3 members, m is equal to 3, and 1, 2, 3, 4, 4 joints, j is equal to 4, and the reaction components are the fixed, and there are 3 reaction components. At the hinge support there are 2 reaction components, 5. The total number of reaction components are equal to 5. Then ds is equal to 3 into 3 plus 5 minus 3 into 4. So this is equal to 14 minus 12. is equal to 2. So the degree of static indeterminacy of this frame is equal to 2. And this and also you can determine using the other approach, ds is equal to dsc plus dsi. So here internally this is determinate as this is a open configuration. So dsi is equal to 0, and the dsc can be determined by using the equation r minus 3. dsc is equal to r minus 3. So r is the total number of reaction components. So dsc is equal to 5 minus 3, this is equal to 2. Here you got dsc is equal to 2 and dsi is equal to 0. So ds is equal to dsc plus dsi, that is equal to 2 plus 0 is equal to 2, and here you got also 2. So by using any one approach you can find out the degree of static indeterminacy. Then the next example, determine the degree of static indeterminacy of a frame. So here this is the frame, and this support is fixed support, and this is the roller support, and here these are the members. So first count the number of members, then number of joints, then number of reaction components. So here the number of members are equal to 1, 2, 3, 4, 5 members, and number of joints are equal to 1, 2, 3, 4, 5, 6. J is equal to 6. Then reaction component, here at the fixed end there are 3 reaction components. At roller support there is 1 reaction component perpendicular to the roller base. So the total number of reaction components are equal to 4. Then find out the degree of static indeterminacy. ds is equal to 3 into 5 plus 4 minus 3 into 6. So this is 19 minus 18 is equal to 1. So the degree of static indeterminacy of this frame is equal to 1. And also you can determine using the other approach. ds is equal to dsc plus dsi. dsi is equal to 0 because this is a open configuration, so the internally determinate, and externally this is indeterminate, and that you can find out using the dsc. dsc is equal to r minus 3. So here r is equal to 4 minus 3 is equal to 1. So this is externally indeterminate but internally determinate. So ds is equal to dsc plus dsi. So dsc is equal to 1 and dsi is equal to 0. So 1 plus 0 is equal to 1. dsc is equal to 1. And here also you got 1. The degree of static indeterminacy of this frame is equal to 1. Then coming to the next example, this is the frame, and here this is hinge support, this is roller support, and this is fixed support. And this is the formula. So using this formula you can determine the degree of static indeterminacy. ds is equal to 3m plus r minus 3j. So here the number of members are equal to 1, 2, 3. M is equal to 3, and the number of joints are equal to 1, 2, 3, 4. 4 joints, and number of reaction components. So this is hinge support. So here there are 2 reaction components. This is fixed support. Here there are 3 reaction components, and this is roller support. Here there is 1 reaction component. So the total number of reaction components are equal to 2 plus 3 plus 1. So is equal to 6. Total number of reaction components are equal to 6. Then find out the degree of static indeterminacy. 3 into 3 plus 6 minus 3 into 4. So here this is 15 minus 12 is equal to 3. So this is the degree of static indeterminacy, and also you can find out the degree of static indeterminacy using the another approach. This is coming to the another example. So here this is the frame, and this end is fixed, this end is fixed, and this is the hinge support. and here the number of members are equal to 1, 2, 3, 4. 4 members. Number of joints are equal to 1, 2, 3, 4, 5. J is equal to 5. And number of reaction components are equal to, here there are 3 reaction components, and here there are 3 reaction components, and here there are 2 reaction components. 3 plus 3 plus 2, 8. R is equal to 8. Then the degree of static indeterminacy can be determined using this formula. ds is equal to 3m plus r minus 3j, 3 into 4 plus 8 minus 3 into 5. This is equal to 20 minus 15 is equal to 5. So the degree of static indeterminacy of this frame is equal to 5. And also you can find out using the other approach. Then coming to the next example, determine the degree of static indeterminacy of a frame. So this is the frame. So here this end is fixed and this end is also fixed, and these are the members. So here how many members? 1, 2, 3, 4, 5. 5 members. M is equal to 5. How many joints? 1, 2, 3, 4, 5, 6. 6. And how many reaction components? 3 plus 3, 6. Then find out what is the degree of static indeterminacy. ds is equal to 3 into 5 plus 6 minus 3 into 6 is equal to 21 minus 18 is equal to 3. So the degree of static indeterminacy of this frame is equal to 3. And this frame is externally indeterminate and internally determinate, because internal this is open configuration. So dsi is equal to 0, and externally dsc is equal to r minus 3. 6 minus 3 is equal to 3. So ds is equal to dsc plus dsi. ds is equal to 3 plus 0, that is equal to 3. So the degree of static indeterminacy you can find out using other approach, this manner. Coming to the next example, here this is the frame, and here this support is fixed, this support is fixed, and here this is hinged and this is hinged. Find out the degree of static indeterminacy using this formula. ds is equal to 3m plus r minus 3j. And first count the number of members. 1, 2, 3, 4, 5. Number of members are equal to 5. Then number of joints, 1, 2, 3, 4, 5, 6. Number of joints are equal to 6. Then total number of reaction components, here 3, here 3, here 2, here 2. So the total number of reaction components are equal to 3 plus 3 plus 2 plus 2. So this is equal to 10. R is equal to 10. Then find out the degree of static indeterminacy is equal to 3 into 5 plus 10 minus 3 into 6. So this is equal to 25 minus 18 is equal to 7. The degree of static indeterminacy of this frame is equal to 7. Also you can find out using the other approach. But here this is externally indeterminate but internally determinate, because this is open configuration. So that internal degree of static indeterminacy is equal to 0, and external static indeterminacy is equal to r minus 3, that is equal to 10 minus 3 is equal to 7. And the total degree of static indeterminacy is equal to dsc plus dsi. 7 plus 0 is equal to 7. So this is your 7. Then coming to the next example, determine the degree of static indeterminacy of a frame. So here this is hinge support, this is hinge support, and this is fixed support, and this is fixed support. And find out the degree of static indeterminacy using this formula. ds is equal to 3m plus r minus 3j. The number of members are equal to 1, 2, 3, 4, 5. M is equal to 5. Number of reaction components 2, 2, 3, 3. So 2 plus 2 plus 3 plus 3. So this is equal to 10. The number of joints are equal to 1, 2, 3, 4, 5, 6. J is equal to 6. Then the degree of static indeterminacy is equal to 3 into 5 plus 10 minus 3 into 6 is equal to 25 minus 18 is equal to 7. Other approach, so you can find out ds is equal to dsc plus dsi, but dsi is equal to 0, because internally this is statically determinate, but externally this is statically indeterminate. So the DSC is equal to R minus 3, because here the reactions are equal to 10 and DSI is equal to 0. So DS is equal to 10 minus 3 is equal to 7. DSC is equal to 7 plus 0, this is equal to 7. Then coming to the next example, determine the degree of static indeterminacy of a frame. So this is the frame, and here these are the supports, 5 support, all are fixed support, and these are the members, and these are the joints. And you can find out the degree of static indeterminacy using this formula. So first you count the number of members, 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of members are equal to 9. Then count number of joints, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. The number of reaction components. So at each fixed end there are 3 reaction components. So there are 5 fixed end. So 5 into 3 is equal to 15. So reaction components are equal to 15. Then find out the degree of static indeterminacy. 3 into 9 plus 15 minus 3 into 10. So this is equal to 42 minus 3 is equal to 12. So this is the degree of static indeterminacy of this frame is equal to 12. Also you can find out using another approach, because this is the open configuration. So this is internally determinate. So DSI is equal to 0, and externally indeterminate. So DSC is equal to R minus 3. So R is equal to 15 minus 3. This is equal to 12. Then the total degree of static indeterminate DSC is equal to DSC plus DSI. This is equal to 12 plus 0 is equal to 12. So DSC is equal to 12. And coming to the another example, determine the degree of static indeterminacy of a frame. So here this is fixed end, and this is the sliding support. Here there are 3 reaction components, and here there are 2 reaction components. So the total number of reaction components are equal to 5, and the total number of members are equal to 2, and total number of joints are equal to 3, J joule 3. Then find out the degree of static indeterminacy. 3 into 2 plus 5 minus 3 into 3. 11 minus 9 is equal to 2. So the degree of static indeterminacy is equal to 2. Also you can find out using another approach. So DS is equal to DSC plus DSI. But here this is internally determinate, because this is open configuration, but externally indeterminate. This is internally determinate but externally indeterminate. So you can find out DSC is equal to R minus 3. So total number of reaction components are equal to 5 minus 3 is equal to 2. Then you can find out DSC is equal to DSC plus DSI. So DSC is equal to 2 plus 0 is equal to 2. That is the degree of static indeterminacy. Coming to another example. So here this support is hinged, this is also hinged, both are hinge support. So total number of reaction components are equal to 4, and the total number of members are equal to 3, total number of joints are equal to 4, J joule 4. Then you can find out the degree of static indeterminacy using this expression. 3 into 3 plus 4 minus 3 into 4 is equal to 13 minus 12 is equal to 1. Also you can find out using another approach. So here, because this is internally determinate, so DSI is equal to 0, and externally indeterminate, so DSC is equal to R minus 3, so R is equal to 4, so DSC is equal to 4 minus 3 is equal to 1, so DSC is equal to 1 plus 0 is equal to 1. So this is the degree of static indeterminacy. Then coming to another example, this is the frame, and here this end is fixed and here this is hinged. and using this formula you can find out the degree of static indeterminacy. So here the number of members are equal to 1, 2, 3, 4, 5, 5 M0 number of reaction components are equal to 3 plus 2, 5. Number of joints are equal to 1, 2, 3, 4, 5, 6. J is equal to 6. The degree of static indeterminacy can be determined using this equation: 3 into 5 plus 5 minus 3 into 6. So this is equal to 20 minus 18 is equal to 2. And also you can find out using other approach, because this is internally statically determinate and externally statically indeterminate. So you have to find out DSC R minus 3, R is equal to 5 minus 3 is equal to 2. But DSI is equal to 0, and then DS is equal to 2 plus 0 is equal to 2. Coming to another example, so this is the frame, and here this end is fixed, this is fixed, and this is hinge support. So find out the degree of static indeterminacy using this formula. So here the number of members are equal to 1, 2, 3, 4, M04. Number of reaction components are equal to 3, 3 plus 2, 8. Number of joints are equal to 1, 2, 3, 4, 5, 5. Then put this value here and find out the degree of static indeterminate. DS is equal to 3 into 4 plus 8 minus 3 into 5 is equal to 20 minus 15 is equal to 5. So this is the degree of static indeterminacy. Also you can find out using the other approach. Coming to the next example, so this is the frame, and here these are members, and this is the support, fixed support, this is the hinge support. So here the number of members are equal to 3, and the number of joints are equal to 4, and number of reaction components here 3, here 2, 5. Then find out degree of static indeterminacy using this formula. DS is equal to 3 into 3 plus 5 minus 3 into 4 is equal to 14 minus 12 is equal to 2. And also you can find out using the other approach. Coming to the another example, this is the frame, and here the support is fixed and this is fixed. Here there are 3 members, 1, 2, 3, and 4 joints, 1, 2, 3, 4, and 6 reaction components. Here 3, 6 reaction component. Then they find out the DS using this formula. DS is equal to 3 into 3 plus 6 minus 3 into 4. So this is 15 minus 12 is equal to 3. This is the degree of static indeterminacy of this frame. Then coming to the another example. So here return the degree of static indeterminacy. So the degree of static indeterminacy using this formula. So this is a closed figure. This is the, so here this is the frame, but here these are the closed loop. These are the closed loops. So here first find out the degree of static indeterminacy using this formula. So first count the number of members: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. Number of members are equal to 21, and number of reaction component. Here this is fixed. So here 3 reaction. So number of reactions are equal to 12, and number of joints are equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Number of joints are equal to 16. Then find out the degree of static indeterminacy. This is equal to 3 into 21 plus 12 minus 3 into 16 is equal to 27. The degree of static indeterminacy is equal to 27. Then find out using the other approach, because this is the closed loops. So this is internally statically indeterminate and externally statically indeterminate. Internally and externally both are indeterminate. So you have to find out DSI and DSC. Then you can find out DSC is equal to DSC plus DSI. So first find out DSI. So here how many chords required to make it open configuration? So here one chord, here second chord, here third chord, here fourth chord, 5 chord and 6 chord. 6 chords are required to make the structure open configuration. So look at this figure. So here this is the one chord, this loop becomes open, and here second chord, this loops become open, third chord, this loop become open, and this is fourth chord, so this loop become open, and this is fifth chord, so this loop become open, and this is sixth chord, so this loop become open. So after cutting 6 chords, the structure becomes completely open. So you can find out what is the degree of static internal indeterminacy using this formula. DSI is equal to 3 into C. So C is the number of chords. Number of chords are equal to 6. So 3 into 6 is equal to 18. So DSI is equal to 18. And find out the degree of static external indeterminacy. So using this formula, DSI is equal to R minus 3. So R is equal to total number of reaction components 12 minus 3 is equal to 9. So this is 9 DSC, DSI 18. So total degree of static indeterminacy is equal to 27. And here also you got this is 27. Then coming to the next example, these are the fixed support, and these are the members, vertical, and these are the horizontal members. So first to find out the number of members, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Number of members are equal to 14, and number of reaction components are equal to 3 plus 3 plus 3 plus 3. Number of reaction components are equal to 12, and number of joints are equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. J is equal to 12. Then by using this formula, you can find out what is the degree of static indeterminacy. ds is equal to 3 into 14 plus 12 minus 3 into 12. So this is equal to 18. And also you can find out using the other approach. So you have to make it open configuration. So here required the number of chords. Here one chord is required, this loop become open. Here one chord required, so this loop become open, and here one chord required, so that this loop become open. So 3 chords required here. So look at this figure. So here this is the first chord, this is second chord, this is third chord. So then you can find out the degree of static internal indeterminacy, that is DSI is equal to 3 into C. So C is the number of chords. So here 3 chords, so 3 into 3, that is equal to 9. So the degree of static internal indeterminacy is equal to 9. The degree of static external indeterminacy can be determined using this formula. DSC is equal to R minus 3, and here R is equal to the total number of reaction components 12. 12 minus 3 is equal to 9. So the degree of static external indeterminacy is equal to 9, and degree of static internal indeterminacy is equal to 9. So the total degree of static indeterminacy is equal to 9 plus 9 is equal to 18. And here also you got 18. Now all are clear how to determine the degree of static indeterminacy of rigid jointed plane frame by using the 2 approaches.